Hey ho, my name is Mario. I'm one of the creators of Libgdx. This video is going to talk about how to set up a basic Libgdx project, run it and debug it on the various platforms, and I'm also going to talk about how to deploy an HTML5 version of your application, but in a very non-fine-grained way. Okay, this is our main website. Features a couple of fancy links. You should totally follow those links because they contain a lot of information. For example, documentation is pretty interesting. Whoever thought there's no documentation is wrong. You can also check out our release nightly and source code thingies. We have a full feature list here, or rather a comprehensive feature list, let's put it that way, with links to Java docs and wiki articles where appropriate. News, pretty interesting. That's an RSS feed of my blog. If you click here, you go to my blog, which loads slowly, very slowly, or doesn't load at all. Yeah, well, it will eventually load. There's also my Twitter account, where I occasionally talk about things related to Libgdx. And there's the forums. You should totally go there, register and ask questions. If you have any questions, first go there, search. If you can't find anything, post a topic. If you get an answer that you might have discovered a bug, then it's emergency time. You should go to the issue tracker on Google Code, which is our main source code hosting platform, and post a new issue. If you post a new issue, give it a descriptive summary. Tell us how to reproduce your problem, what the expected output is, and give us some information. Say your Android device, what kind of device it is, your Android version, your browser, your desktop setup, and so on and so forth. Just anything you can think of that could potentially have an impact on the problem at hand. So that's the general overview. Again, I would suggest that you explore this site and also explore the wiki, which is growing at a fast pace. We are only lacking a few minor things, or rather the entire graphics section. I'm going to work on that. But it's pretty comprehensive. Also, there's external tutorials which walk you through the creation of full games. Check this out. There are a couple of things you need before you can start developing with Libgdx. There's a wiki page for that. So let's go here. What you need is the JDK, which is the Java Development Kit used for general Java development. Eclipse, which is our preferred IDE. You can use other IDEs as well, but Eclipse will probably have the least friction because Google endorses it as well with its Android development tools as well as the Google Web Toolkit. So if you like Eclipse, I'm happy for you. If you don't, I'm sorry, because setting things up in other IDEs might be a little bit of a pain. There are articles on the web that describe how to do that. So assuming you have all of that installed and configured correctly so that you have a fancy Eclipse workspace that's waiting for our projects to be imported, we can fetch either the release or nightly build. So go to download and source, choose one of those. I generally go with the nightlies. Well, actually I'm working on the SVN trunk, so I don't use either of those, but let's assume I would be a user. I'd go with the nightlies because they're as stable as the releases, feature new features and bug fixes. I already downloaded the nightlies, of course, because I'm prepared, and extracted them here. The content of this zip file is described on this page if you're interested. You don't necessarily need to know what this is unless you want to set things up in a different IDE. Then you have this fancy page here. What we are going to use instead is the GDX Setup UI, which is a nice contribution by Obli, also known as Aurélien Ribon. I hope I pronounced that correctly. He's been an active member for a long time, and he's contributing a lot of cool stuff to Libgdx. So what this thing does is, and you can start it either by double clicking in Windows, or you go to the command line and say, whoopsie daisies, java-jar GDX setup UI will do the same thing, as you can see. So what this thing will do is it will create the projects, the Eclipse projects necessary for, or rather the skeleton for a Libgdx application in terms of Eclipse projects that we can easily import into Eclipse and start working with. So let's go through this real quick. The configuration pane lets you specify the name, package and class name, or main game class name, as well as the output destination, which we are going to change. I call it my game. Right. The second pane allows you to either specify whether you want to use the stable version or the nightly version, which will be downloaded if you click one of these. Okay. But we already downloaded it, so we click on the browse button and select the zip file here. Upcoming versions of this tool will probably notice that they are inside of the extracted content of the zip file, so you don't have to do this. Third-party things, I'm not going to talk about that. This is actually dynamic. We have kind of a package system in place now thanks to Obli. He already added his extensions or third-party libraries. This one is especially interesting. Look it up on the web, it's pretty cool stuff. And this will be how our output will look like. So we're going to talk about this setup in a bit. Let's change it to projects. Ta-da, and it's done. There's a couple of things you can look into if you have questions. Okay, that's all we need to do. So, in our downloads folder, we now have those 4 projects, and we can easily import them into Eclipse. So go to File, Import, Existing Projects, Browse. Find your downloads folder in this mess that's called the file system. And there's our 4 projects, and we are ready to go. Once imported, you will see that there's a little problem with the HTML project. The reason being that the GWT plugin doesn't automatically copy a necessary jar in here, which it should do. It's pretty easy to fix. Go to your problems pane, go to errors, right click on this thing, say quick fix, and click finish. Just ignore anything, don't read anything, reading is for pussies. Everything compiles now, so we can talk about the project structure. Libgdx is cross-platform. It allows you to deploy to desktop, Android, and browser platforms. And all of those different ports, so to speak, share the same code base. The code for your game will be located in this core project, and you can put as many classes, whatever you have, in here. And all the other projects, which are responsible for starting up your application on the respective platform, will just use the code found here. So the other projects are the Android project, which only has a single class. All of those things do the same. They create an application for this platform, in this case an Android application, which is an activity, an Android activity. They configure things, and then they initialize themselves so the actual game is executed on that platform. Same is true for the desktop backend. There we go. So we have a main class here with a main method. Again, we configure a couple of things, and then we start off an LWGGL application which runs our game. Then we have the HTML project. It's the same story. We have a GWT application which asks for a configuration, and the so-called application listener, which is our game, and it will do the fancy trick to run our stuff in the browser. Okay, now that we know about the project structure, we can look into our actual game class. The setup UI will fill out things with kind of a demo application which displays the Libgdx logo. The amount of lines of code you see here is actually a little bit, how should I say, high. You can do this in a lot less number of lines of code. But it just demonstrates a couple of best practices for very basic 2D graphics. In any case, let's make this big. Our main application will implement the application listener interface, which is a couple of methods that get called during the life of our application. It starts out with a call to create, which only happens once. After that, you usually get a resize call, which tells you about the width and height of your application. From there on, it calls the application will will call the render method all the time, or at least as fast as possible, where you will do your rendering and your logic updates. On Android, your application can get paused and resumed. Then you get calls to those two methods. If your application is paused, there's of course no rendering done. After you resume, you usually also get another resize call. If something changed, say the orientation of your application, then it's back to rendering. Finally, when your application gets closed, you'll get a call to pause to indicate that your application is now paused, and then you get a call to dispose, which tells you that the application is now going to get killed. That's the same for all platforms. Okay, the details of this class can be found on the wiki, so just go to documentation, click on the wiki link, and read through all those application framework things. Those explain to you what the basic life cycle of an Libgdx application is on different platforms. Okay, now it's time that we run our application on different backends or platforms. We start off with the desktop platform, so right-click your desktop project, select Run as Java Application, then select the main class, and this is the end result. We just display this fancy logo thingy here. We can do the same on Android. I have an Android device connected, so I go to Run as Android Application. I can show you the screen of the application on my Android phone, but I can make a screenshot while it's running. Oh, it seems like nope. There we go. Okay, there we go. So I just need to restart it again. Okay, let me take a screenshot real quick. Come on. Yeah, so it's now running on my Galaxy Nexus. And finally, we can run it in the browser. For that, we use the Google Web Toolkit. It has two ways of running an application. One is to run it in development mode. That is, it will start a local server, a Chatty instance in Eclipse, and then deploy your application temporarily to that, so you can browse to it in your browser. Right-click it, run as web application. This will do a couple of things in the background, like compiling your application. So just click on this URL here. Oopsie. That will bring up your browser. The first time you're doing this, it will ask you to install a plugin for GWT for your browser. Just do that. In the background, it will compile your code, your Java code, to JavaScript and inject it into this thingy thing. Don't ask me how exactly it does that. It's all magic to me. Eventually it will show up in your browser. So this is now running on pure JavaScript with WebGL as the rendering technology, because we got the technology. Don't get irritated by that. That's pretty much normal. It doesn't impact anything. Okay, so now we know how to run things. The next thing is how to debug things, and if you're used to Eclipse and Java, you already know how this works. So right-click, debug as Java Application. We want to run or debug the main class, so it's started up now. Set a breakpoint. I can do the usual thing, that is step through my code. I can watch variables and so on and so forth. So that works brilliantly. The real cool thing about this is that we can change our code on the fly while it's running, and Eclipse will recompile our code and inject it into the running JVM. There's some limitations to that. You can't add new methods or new fields, but if you structure your code correctly, or rather with regards to this feature, you can do a lot of tweaking just by modifying your code while running your application in debug mode. That being said, you will do most of your development on a desktop, just for the simple fact that starting up your application is really fast on a desktop. And in addition to the code hot swapping, there's no real reason why you should deploy to Android all the time, unless you're doing performance testing and stuff like that. Same is true for the HTML5 backend. So debugging on Android is the same deal. Just right click, debug as Android, and it will deploy the APK again. eventually spin up the debugger, and oh, we can set a breakpoint. Hello. And this is now running on my phone. You can't do code hot swapping on Android yet. I hope eventually they might be able to implement that. That would be a fancy feature. But you have all the other stuff like stepping and variable observing. Finally, you can do the same thing for GWT or HTML5 backend. Just right-click the project, debug as web application. Does the same old thing. We'll present you with an URL. Click it, open it in the browser, compiles your code, runs it in the browser. As you can see, whoopsie, there we go. We can set a breakpoint. We can step over things. We can watch variables, and I think you can actually do the fancy code hot swapping as well. So I just let it run. Oops, that wasn't too smart. So I changed the background color, and it says no, it can't do that. I have a feeling that it actually eventually sometimes works. I haven't figured out when it works and when it doesn't work. All that being said, development mode is really slow. It's not indicative of the real performance of the application once it's compiled. So don't use it for benchmarking. It's the same pretty much as the emulator for Android. Just don't use it. It's pretty much useless in our case because 60 frames per second with all the instrumentation doesn't work at all. So what you would actually do if you want to test your HTML game is that you compile it. So right click your project, go to Google, GWT compile. Now this little thing needs changing, so remove it and add the actual entry point. All of the parameters are pretty much okay. We could make it faster, but that should work. So let's compile this beast, and as you will see, compiling takes quite a bit of time. It's between 20 seconds, 1 minute, depending on your project size. It could be even more. Doesn't concern us too much. As I said, we will usually work on a desktop most of the time and only occasionally deploy to Android or the browser. The output of the compilation step is interesting. We sadly have to wait until it's done. What you end up with is a folder containing your assets, a folder containing your JavaScript code, which is the Java to JavaScript compiled code, and this index.html, which you would probably replace with your own HTML file or PHP file or whatever you have that will call into the JavaScript file, so your game actually starts running in the browser. So as you can see, we now have this assets folder, the folder containing the JavaScript. For each browser there's a specific version, and the index.html. Now to actually run this, you can just click here for obvious reasons. You actually have to put it in, you have to serve it from a real web server. So what I usually do is I have a local nginx installation, and I just put this war directory in here. Oh god, I copied the webinf folder. So yeah, you don't need this folder. This is really only used for development mode. So assets, the com something something plus your HTML file, and then you can, provided that you have an Apache or nginx or other web server running, localhost war. The application will be served from that server, and that actually allows you to test performance and so on and so forth, which is pretty good if you remember those little demos I showed earlier. I think this one here, for example, it's a simple 3D game and it works at 60 frames per second. The screencasting software probably doesn't show you the frame rate, but it's pretty fast. Okay, so now we know how to create our projects, run them, debug them, and actually deploy an HTML5 project. Okay, and that's pretty much it. Where to go from here? I would say this page is really valuable. Go here and just plow through all the things you see. You can learn a lot just from looking at the examples, which are all open source, of course, and also walking yourself through those tutorials by third parties. Yeah, good luck, have fun.